All right, so we're gonna look at the question you may have. I know some people says they need help with the last section, but I just want to make sure everybody on the right track. So that just say if I have ever have this cosine inverse of actually tan cosine inverse of negative root 3 over 2 like this. I want to make sure everybody understand this before we go on. This is what we did yesterday. So everybody try to do it right now and see what you get. And that's good. Like testing of where your knowledge is, and we can and you should get done around 40 seconds. Done? Okay, give me a second, I'll call you. I should make sure everybody know. So without getting help from someone else, did you already get an answer, first of all?
Yeah.
Yes, good. Okay, so Ian, what do you think the answer is?
1 over negative root 3. Well,
1 over negative root 3 is not wrong, but it's not finalized yet, not rationalized yet. Root 3 over 3, negative or positive? Okay, how many of you guys got negative root 3 over 3? How many of you guys have not? Okay, so Louis, where you get confused?
I just didn't know how to rationalize.
Oh, okay, so I'll show you how to do that part. That's fine. Rationalize is not a big part. So at least everybody start understand a little bit better. At least if what you telling me is true. I'd rather you telling me says I don't understand how to rationalize or I got it wrong. Because you are becoming better student if you got it right. If you had to lie to yourself, says, oh, I didn't get it right, but I'm gonna just raise a hand so I don't embarrass myself. There's no reason to do that. I'm not embarrassing you, not in any way. Like I will never do anything like that. I'll embarrass you differently, but I won't do like just like you did bad. Okay, so this one's gonna cosine inverse of negative square root 3 over 2. You always start from inside, right? So inside it's gonna be 2 pi over 3. Hopefully you got that. No, actually it's no 5 pi over 6. I did it wrong. Sorry, 5 pi over 6. So tangent of 5 pi over 6 is gonna be square root 3 over 3 negative. So this is my answer. So I start from understand what is radian for this, and I got 5 pi over 6, and I do tangent of 5 pi over 6. Yesterday we already talked about those 3 lines. Tangent of pi over 4 is equal to 1. That's easiest one. That don't need to memorize. The only thing that you need to memorize is pi over 6 is root 3 over 3, and tangent of pi over 3, that is going to give you square root 3. And so if you got 1 over root 3 and you rationalize, you multiply by square root 3, square root top and bottom. So it'd be square root 3 over 3. And that's how you get it, Louis. Yeah.
Why is it 5 pi over 6, not just pi over 6? Or negative pi over 6?
Because the negative pi over 6 is right here. Okay, so your x still positive. the only way that x is negative has to be second or third, but the restriction of cosine inverse is restricted at second. So you don't have the third as an answer. Any questions? Jesus, it doesn't really take long. You could have done it. But you can keep on lie to yourself, says you don't have enough time, and that's what you will do. But just don't look for excuses. Just get it done. It's not a big deal. This homework can be done in 5 minutes. So honest, yes.
For example, like for tangent, if any value is like pi over 6, is it always gonna be like root 3 over 3?
Yes.
Okay.
But there's some positive negative. So let's say first and third quadrant is always positive, second and fourth is always negative, because you're gonna get third quadrant you got negative x over negative y. That's why it's positive. And first quadrant is positive over positive. But if you have second and fourth, you're gonna get negative over positive, positive over negative. That's when you get negative signs. Does that make sense?
Yeah.
So Leah, this is the first time I've seen you ask a question. I mean, for a while. So I'd rather you guys ask question before you leave, rather than you go home and absolutely lost. That's not my goal to make you like feel like a lot of time. I always make fun of my classes. My class give people mental health issues, but the problem is it doesn't have to be. You could go home before you go home. You understand that you finish your homework very quickly, and that's much better than you just completely don't know when you go home and stare at the homework for a half hour, and you cannot go anywhere. And I'd rather you ask me questions. Okay, so next questions. So a lot of people says I don't know how to do the certain parts, but those parts are actually relative easy. So we're gonna go to inverse trig. Wait, what is that? So this one. Okay, so this is the work I got. I don't know if you guys need help with this one. Doesn't anybody need help? If you need help, just raise your hand. Marley, if you need help, ask the questions.
Yeah, I'm just looking at like the best way to I think. Well, cosecant.
Okay, cosecant E. Okay. So first of all, I will do is I will go to determine which quadrant is this. So tan inverse, it's very easy to decide tan inverse. So I'm going to go with the right 2 quadrant, just like the arc sine. Okay, by the way, you should know arc, sine, and sine inverse are the same thing. Sometimes I can ask you arc sine or sine inverse. That means the exact same thing math notation wise. So write it down if you don't know. Arc sine and sine are exact same thing. Or arc tan or tan inverse, they are the same thing. Vice versa for all other trig function. So you guys need to know that. So I can ask you different wording and you gotta be able to just adjust it. AP exam might be ask you arc sine rather than sine inverse, right? So now we decide this quadrant is this tangent negative inverse is gonna be this 2 quadrant. Now since this is negative, has to be in this quadrant. So I put a double check mark there. And I draw a reference triangle. Again, it has to be certain orientation. And so this is a 1, 3. This is just means one of them is y value, one of them is x value. So which one is y value? Well, this one's y value is 1, but how do I know it's x or y? It could be on x, could be on y, because on the second quadrant it's going to be different. So since it's below here, it has to be -1 here because it's below. and this has to be 3, there's no other chance. You cannot get -3 positive 1, right? So here we're going to use Pythagorean identity if we got the square root 10. Now I'm going to say, well, this represents the data. So cosecant of data is equal to hypotenuse over opposite. So hypotenuse square root 10 over opposite is going to be -1. So it'd be -√10. And that's the final answers.
For the y and x intercept, is it just because tan is y over x, and then -1 is going to be y?
Yes. And then it's negative is below x-axis. Yes.
If you have, like, on these, if you have the cos or the inverse on the outside, how would you know which quadrant?
So inverses outside only occur at this this situation. So for example, like 10, 10 inverse. So 10 inverse, I'll figure out what a 10 of 2 pi over 3 is. Well, what's 10 of 2 pi over 3?
The half, no. I don't know if it'd be rational.
Negative root 3. So just memorize this diagram I kind of show you. Where did I write it down? I write it down earlier. So for tangent, just knowing tangent of pi over 4. This one you don't need to memorize. The only one you need to memorize is tangent of pi over 6. That's going to be root 3 over 3. Now, anything pi over 3 is going to give you root 3. So it's everything in terms of pi over 3. So now, what is 10 inverse of negative pi over 3? Why is it negative? Because 10 inverse, no, sorry. Hold on a second. The 2 pi over 3 is going to be, sorry. This one is going to be negative root 3. Now, negative root 3 has to be negative pi over 3 because the 10 inverse has the right 2 quadrant. So, but since it's a negative root 3, so it has to be negative pi over 3. Okay, so this question, everybody's okay? Yes.
I have a question about,
For E, for this, yeah.
did you want us to leave it as radical 24?
I mean, I should rationalize. I was going too fast, but you should get square root 24 over 24, and you should take out 2, 6 over 24, and 12, and square root 6 over 12 will be final answer. Now, some of you guys, like Jada yesterday asked me, says, I don't know how to simplify radical. So, and that's okay. You got it. No, so she have a square root 10, and she got 2 square root 5. Right, Jada? And that's okay. But you gotta tell me that you don't know. Right? So again, if you still don't know how to simplify radical, this is 2, 5, there's nothing to form a group of. Okay? But square root 20, you can do 2 and 10, and 2 and 5. So some people like Bennett says, I don't know how to rationalize something. You got to learn. You cannot just say, I don't know. Maybe somewhere magical later, I'm going to pick it up. So you cannot do that. So, right, I can put this out. It's going to be 2 group of 5. And that's how you simplify radicals. If you don't know, learn it. Like, I don't have no problem you don't know how to do anything. I have a problem you don't ask. Like, I have a student don't know how to do 32 times 8 in calculus last year. She never asked me, but she didn't know how to do it. Eventually, I forced her to ask me in front of the whole class because I didn't know. She write on the test, she said 32 times 8, she do 32 plus 32 plus 32 plus 32, 8 times. And I was wondering why she cannot finish her test until I see when I grade her test, I see that. But you can ask me, it will solve your problem. Don't be embarrassed. I don't think in this classroom anybody's immature enough to say, oh, how come you're so stupid? You don't know how to do that. Nobody will tell you that. At least I think everybody's mature enough to do that. And I am gonna be fine if you ask me. I'm not gonna say, hey, I'm not gonna answer your question. Now for this question is all the answer here. Now I choose to rationalize this, but at this particular question, I don't need to rationalize just because I think it's already a lot of writing already. So the truth is about rationalize. The simple one I need to rationalize. This kind of stuff I don't need to just because rationalize is just a way for teacher to grade it easily. It's not because of anything else. Let me know if you have any questions. Now I know question's gonna be the last one. This one's okay, right? This one's on the test. This one's on the test. This is on the test. This is on the test. Everything's on the test except this question. Except this question. I'll tell you how to do that. Those people you care. This is my answer for this one. Now I know there's a lot of questions here. Usually people get it and get it right away. People don't get it, they don't get it. But let me know you have questions. Start with one question. Yes. Okay. I thought it's a good choice. Because if you do cosine inverse of cosine of 11 pi over 8, first of all, you had to determine what's 11 pi over 8. Which quadrant is 11 pi over 8? Third. Good. So that's going to be third quadrant. It's going to be closer to y-axis or closer to x-axis? It's going to be closer to y because this is what? 8 pi over 8, right? This is 16 pi over 8, right? So that makes this one 12 pi over 8. Does that make sense? So it's going to be right here. How wide is this reference angle? That's why you need to know the reference angle. What is that reference angle? That's why I need you to ask. This is a different way to ask reference angle. What is the reference angle here? What? No, that's not in terms of pi over 6. Huh? No. Reference angle is what? No, it's always positive. Reference angle is always positive. 3 pi over 8. So this is a 3 pi over 8. Why is it 3 pi over 8? Because 11 pi is the closest to the closest angle from with the closest x-axis. So this is going 11 pi over 8. This is 8 pi over 8. That's the difference. 3 pi over 8. So you say, oh, okay, it's 3 pi over 8. But you want the same result as 11 pi over 8. You want the same result for the cosine inverse. So therefore, it has to be, cosine inverse has to be in this quadrant. Does that make sense? And this has 3 pi over 8, but that's not how the way to calculate angle. The way to calculate angle is from here to here. So what's my final answer? 5 pi over 8. So that's 5 pi over 8. Kind of difficult.
How is it split onto like the second quadrant?
Because you know cosine inverse has to be first or second quadrant. Yeah. And it's not going to be first because first you're going to get positive value. I hear you get negative x, right? Because I hear cosine, whatever it is, I don't know the result because it's not in the unit circle. But I know cosine of 11 pi over 3 is going to be negative. So only way it can translate to the negative, it has to be in the second quadrant. Yeah, okay, give me a second, Charlotte. Reference angle is not 16 pi over 8.
Starting with that and not inverse.
Oh, I think I know what you're saying. You say this is 3 pi over 8. Why didn't I just put down 3 pi over 8, right? Because the way we calculate angle is from the x-axis. So it's gonna be 3 pi over 8 this way, so you need to count. It's gonna be 4 pi over 8, 5 pi over 8. So it's gonna be 5 pi over 8. Are you sure?
That makes sense.
Okay. All right. Austin, you said G?
Yeah.
Okay. G is gonna be negative pi over 5. So negative pi over 5 is which quadrant? Fourth, right? And this is negative pi over 5. But this is negative pi over 5. Therefore, the sine inverse has to give you the same thing. The sine inverse has to give you the same thing, so the answer is going to be negative pi over 5, because that's the only way to get you the same value. It cannot be positive pi over 5, because the only two choices you have is positive pi over and negative pi over 5. But in this case, it's negative pi over 5. Other questions? I like this question. It's very, make sure you know your reference angle. Yes.
Can we do C?
C. Okay. 7 pi over 5. Which quadrant is this, Emily?
The third one?
Third quadrant. Good. Now, can you tell me what's a reference angle? Everybody should think as well, besides Emily. But she's the one to ask questions, so I make sure she understands.
I don't know, just because if it's like 5 pi over 5.
Right. So here's 5 pi over 5.
Like if you're looking at the y-axis.
No,
right?
you're looking at the closest x-axis.
Okay.
So always reference angle is formed with the line, the terminal side, and the closest
So it would
x-axis.
be 10, like 10 pi over 5.
No.
But like, is that what you're referencing, or are you referencing like the middle value?
So which x-axis that's the closest? The on the left side or the right side? Okay, so we're gonna draw a line here. This is 5 pi over 5, right? And this is 7 pi over 5. Now, what do you think the reference angle is?
Is it 2 over 5?
Yep, 2 pi over 5. That's it. It's that easy. So this side is 2 pi over 5. But you know this is going to give me negative value, right? Negative value. Why? Because it's going to be below x-axis. The only way to get negative value on the other side, you have to have a mirror to the other side to this. Ian, do you understand? It has to be mirrored to this side, and this is 2 pi over 5. Now, since this 2 pi over 5 is going to go this way, the answer is going to be negative 2 pi over 5. That's it.
Wait, why do you flip it to the other side?
Because
On the
if you know sine of 7 pi over 5, it's going to be positive or negative.
negative?
Why is negative? Like, you got to ask yourself those questions. Yes.
Ratio is negative.
No, it's not ratio, it's negative. Why is it negative?
Oh, because the wait. I don't know.
Can somebody tell why it's negative? It's below the x-axis. Your triangle has a below the x-axis. Since sine is y, y is below the x-axis, has to be negative. See, this has to be negative value, negative number here. So if sine inverse is negative, only thing can happen is the fourth quadrant. Does that make sense? So it has to be here. And this is a question that you want to do. It says negative 2 pi over. This question are very hard. Trust me. If you ask 99% of pre-cal students, nobody can answer those questions. The only people who can answer those questions, usually they only be in my class. Not gonna be anywhere else. Questions? Yes, Alpha. You just she goes like this. I'm like, okay, sure. This is a good worksheet to start study with. The one I written down, there was some back question. I wasn't, my brain's not working as after school, so yes.
So does the triangle only ever like reflect across the X or Y, like never the oranges?
No. Very good question. Now I want you to think of why not. Which trig function doesn't require? Yes. So I had to think about all the process inside my head. I was like, I have to eliminate all the choice inside my head. I was like, well, that's true for sine because we reflect across y-axis. It's true for cosine because we cross x-axis. But then I was like, shit, the tangent doesn't work. So I thought that's a great question. You and your brother always come up with a question trying to trick me. That's why I can't stand your brother. Your brother's always like, what if this? And I'm like, Daniel, damn it, you had to make me think. Yes, Charlotte.
See the referencing.
Two pi over 5. Because the reference angle is going to be formed with the closest axis and it's always positive.
Why is the inverse on the bottom and not like? Why isn't it in the first quadrant?
It's not in the first quadrant. It's at the fourth quadrant because inverse has to be first and fourth. But since we know that sine of 7 pi over 5 is going to give you a negative value, so therefore it has to be at fourth. She says okay, but she still don't get it.
I'm like processing.
That's okay. Processing is good. Sometimes you have to make those neurons inside your brain like interact with each other, and that processing is fine. I know this class is challenging for some of you guys, and that's okay. You just have to keep on overcoming. You're not getting smarter by just sit there to say, I can't do it. I give up. It's too hard. Which that's what some of you guys do. But I don't train quitters. I don't think none of you guys are quitter. I don't think any of you guys are quitter. Any other questions? Okay, so that we spend some time to understand. So we have 15 minutes to teach new stuff, which is okay. Make sure you review this because this can be on top. Grab that. People getting old.
Thank you.
You're not old. You're like 15 years old.
Okay, but I run, so my butt's here.
Or 14. Wait, 14? I wish I'm 14. Sometimes I want to think like, what's this kid's name? I remember she was in my class last year. I can think of them. All right. We finish out a graph. We finish out an inverse. And I'm really, I would really want to pass the test back, but I'm just really tired. So I'm recruiting some grader for me. If you want to help me grade, I'll give you the answer key. You can grade them in front of me. But so that means you cannot grade your friend's paper, but you can grade other people. And give you hours, volunteer hours, or extra credit, doesn't matter which form. So if you're interested, let me know, because I'm too tired grading. Okay, so what we're gonna do is we're gonna start with the next section, but the next section is hard. A second. Should I talk about the section? The applications. Oh, and also SAT, if you guys are interested in taking March SAT, yes, I'm gonna have I will do a free section of training section for 2 hours. Probably gonna be like somewhere after school or on a Zoom. But you have to register because I think the last day to register is February 25th. So yeah. Okay, so I don't have much time, so I can come back and teach this. Okay. Also, I'm gonna give you some question that's regarding using calculator, but I'm gonna give you as a homework, but I'm not. I'm just gonna go to the next chapter. Okay, so the next chapter, what I want you to do is knowing all those identities. So everybody need to know this 3 identities. So do you guys know that there is triangle? And there's a right triangle. We're gonna call this one is A, B, C. And this is a theta. Man, that's ugly. Let me redraw this again. Maybe I need a better paper. So imagine that I have a triangle. And this is a right triangle. And this is A. This is a B. This is a C. Now, the way AP exam or any exam to arrange your angle, you gotta make sure this. If this is A, where's the angle A? Huh? Across. Always across. This gonna be angle A like this. That's called you need to know this basic idea for your AP exam. Make sure you know this. Yen, pay attention. If that side is non-capital A, the crossing side has to be angle A. Got it? I'm gonna give you some SAT question regarding to this because I saw it online. Is that okay? So can you label B and C? B, sorry, this is B, right? And this is C. Is that okay? So we know Pythagorean identities A squared plus B squared is equal to C squared. We know this. What else do we know? Well, we know that, hey, let's divide everything by C squared. So I'm going to take this. Yen, you want to copy down? I'm going to double check your notes later. And you better show me that you have notes. Otherwise, you cannot leave until you finish copying. So either you have choice to stay here. Okay. A squared over C squared plus B squared over C squared equal to C squared over C squared. What did I do? I did everything divided by C squared. What does it happen on the right side? C squared over C squared is what? What's A over C squared plus B over C squared? So that becomes a new identity. Why? Because A over C is also known as the opposite over what? Hypotenuse square. Does that look familiar? B over C is adjacent over hypotenuse. squared is equal to 1. I will give you a quiz just asking this next week. So what is opposite over hypotenuse? Sine theta plus cosine theta but square. Now I can write square like this. I can also write it differently. You can also write it like this. Actually, it's much better to write like this. It's between the argument and the trig function. This is the first trig identity. So this is called Pythagorean identity. Yen, you better have a copy done before you leave.
Well, feeling, but it is.
Okay. I just want to make sure because later on you're gonna say, oh no. Pythagorean. This is called Pythagorean identity for trig. We know a squared plus b squared equal to c squared is a Pythagorean identity for geometry, but this is the first time we learn about trig. What we're gonna do is going to divide another two. Louis, put your phone away. Sine square of theta plus cosine square of theta. I can choose to divide it by sine square theta. Why sine square theta? Because I'm going to form a different identity here. What is sine square over sine square? Just 1. What is cosine square over sine square? Not 10. Cotangent. Now remember, I write the square between the theta. You have to write theta. On your quiz, if you don't write down theta, that's wrong because you cannot have a trig function without argument. That's going to be c as c squared theta. Why? Because 1 over sine is cosecant. So that becomes the second Pythagorean identity. We can do one more. You're going to do the last one. I'm going to take the sine square. Instead of divided by sine square, what do I divide it by? Okay, so you're going to try this one. You got a new identity after that. What is sine over cosine? Marley, what's sine over cosine? Good. What is cosine over cosine? What's 1 over cosine? You just form 3 very important trig identity. Okay, 3 very important trig identity. Yes. Sine of cosine is, remember, that is the identity, because think about it, tangent of theta is equal to opposite over adjacent. I didn't give you the identity. That's good. Good that you asked because I just kind of take for granted. Opposite over adjacent. Now, can I say that's opposite over hypotenuse over adjacent over hypotenuse? Because I can divide it by hypotenuse top and bottom. And that is going to give me sine of theta over cosine theta. That's actually first time people ask me that question. Why that is. That's a great question. So tangent of theta is equal to sine theta over cosine theta. Same thing is cotangent of theta is equal to cosine theta over sine theta. So that is called quotient identity. You had to memorize all 3, and you had to memorize how to prove it, because I'll ask you on Monday. Have you seen like when you grow up? Have you guys, your parents read you that book, Brown Bear, What Do You See? Who have read that? You did? Oh, okay. Okay. I thought it was only one reader to my kids. No, because like I think like that's like a very famous book when you grow up, and it's like basically like you see a picture of brown bear, and like the brown bear, what do you see? And you see it like you see a yellow dog looking at me. Do you remember that book? And there was like the next page, it has a blue horse. It's like yellow dog, what do you see? You see a blue horse looking at me. Okay. So I'm gonna the reason why I'm gonna build this lesson to next week. So for me right now, I'm gonna call this is the brown bear. This is a big deal. This is a sometimes you're gonna have to see the brown bear. Okay. Um, and I'm gonna call this a yellow dog. And blue horse. Okay, so but later we're gonna see that. I'll send you a link of that. Somebody read that book. It's like very well-known, famous child book author. Okay, how much time I have? I have 3 minutes. Okay, so that's okay. So now we got understanding. So now let's talk about 3 minutes. What can we talk about 3 minutes? We're gonna talk about even and odd function. So this one is another one. So if you have sine of negative x, it's gonna be negative sine of x because they are odd function. Because if you plug in negative x, right, that's gonna give you a negative sine of x. How about cosine of negative x? What do you think it's gonna be? It's actually positive. It is even function. Why is it even function? Because you think about cosine graph, right? Cosine graph start like this, right? If I pick this here is going to be the same output as the other side is the positive function. So that makes cosecant of negative x is what?
Still gonna be positive, right?
It's actually negative. Yeah, cosecant is sine. Yeah. And the secant of negative x is what? Secant of x. Good, because they are even function, just like cosine. Now, tangent of negative x is negative 10 of x. And cotangent of negative x is equal to negative cotan of x. Okay, so that's it for the day. After school, lunch.
You can take that this way.
Okay, come on lunch. Oh yeah, that's right.
Triangle about
Yeah.
8 1.
Okay. Huh? Okay. I'll see you after school or lunch. Okay, cool.
Have a good day.
When do you need to have a drink?
Lunchtime, but I might have enough people, but you can come.
Okay, during lunch today?
Yeah.
Okay.
You guys ready?
Depends on which upper kids. You should let us know now because every other class is going to be able to know that it is before they take the test.
Why? What do you mean?
Someone's going to tell them.
Oh,
Yeah.
I won't worry about it. I'll play a little trick.
So you have multiple different ones?
Huh?
I assume that you had multiple different ones.
No,
So
Okay.
are you happy to know
I'm
that?
starting to get work.
I mean,
I'm not worried about those.
oh no, wait,
This is the best way to find I find people cheat.
well, are you changing the answer by like a negative? I'm assuming that's easy to do.
I have caught people cheating. And I
You've already done your run?
I printed it at home. It was serious.
Whoa! Wait.
I just need to see Omar before the bell rings. He's gonna cheat.
So test right now?
uh-huh. That's right now, sure.
Dude, no. No, it's weird that she like fighting out across campus running to turn on his papers.
How did you feel walking into this class?
My heart is like racing.
Why are your heart racing?
I don't know.
Omar was talking about that. He couldn't back it up.
I was playing in the job.
I was driving. You lost twice too. Twice. Even Nathan gave up after one.
If I would give up.
Yeah, we keep losing.
That's the thing. So I'm gonna take like 2 years time out.
Well, you look at you want to
Documents funny.
Let's go. For you know, for
I swear to God.
you knew when you walked in that city for Israel. You knew. In your head.
No, because that's the one that I was kind of.
How much I
That's the one that everybody did.
You know, I'm calling. It's gonna be one of those.
Hey, don't put anything out
Oh
there.
my God.
Give me inspiration.
And then.
No, don't
maybe
put
make it-
smoke. Don't put anything out there. I'm fine.
Just remember, there's always gummy bears on the table.
What?
There's always gummy bears on the line, you know?
What do you mean gummy bear?
Like I could, you know, I know a guy who works somewhere to get us stuff gummy bears. In large amounts of gummy bears.
What kind of test question you want?
Give me some
I got ice on my veins. According to Mr. Gates.
Wait, Omar. Don't you work at Publix?
Yeah.
You think you get a discount for gummy bears?
I don't get a discount.
What?
At my gym, I met the guy who owns his store, and he's Arab. So he said, "Oh, give me a Habibi," and I said, "So I'll get a discount."
Wait, where's your
I have slight problem.
All the rooms are down. All the rooms are down.
No, I have slight problem.
Oh no.
What's this like problem?
It's my internet's not working.
Oh. A push essay.
No.
Oh no.
Oh.
Dog, we're so
Worse. Oh.
My Wi-Fi's not working. I cannot get a file.
Be done tomorrow.
Hey,
Somebody write my obituary already. Like.
My damn. My internet's not working.
Yeah.
Someone write my obituary. I know. Just tell me now, like honestly.
Oh, you check your up. There's my test.
I can't even search for. I can't even search for anything.
So is it time to get on the whiteboards and start studying? Is that what I'm hearing?
That means we're gonna go to the next topic.
Next
topic.
one. So
Wait, that's on the test tomorrow?
No.
Wait, what?